Alright, we are looking over learning target G Retake Ticket. Here are the steps to solving a missing side length on a triangle. We're going to use SOHCAHTOA today, and we'll get started with number one. First step is to circle your angle and immediately identify your opposite side. I always then like to go to my hypotenuse. The hypotenuse is across from the 90, and then that leaves only one choice for your adjacent side. Now, the reason we need to identify those is because we don't know which trig function to use. Each function matches up two sides of the triangle, and so you have to pick the appropriate two sides. We look at the side that we don't know. The one we're trying to find is x. The one that we do know is 35 here. This is the opposite, and this is the hypotenuse. So we need a trig function that uses opposite and hypotenuse. If you look at SOHCAHTOA, that resulting function would be sine. So you're going to take the sine of an angle. The angle is 33, and that is equal to opposite over hypotenuse. And again, the order, the sign of on top is opposite, bottom is hypotenuse, matches up right from SOHCAHTOA. So this is a really nice shortcut that can really put us in a good spot to figure out these trig ratios and solve for these missing side lengths. Now, some teachers do it differently, but I like to put this as a proportion. We cross multiply this way, it's just x. This direction, it's 35 times the sine of 33. And when you cross multiply and actually type this into your calculator, 35 times the sine of 33, you end up with x being 19.062. We'll round that to 19.1. Second problem, here again, same idea, basic triangle. We start with the angle. We say across from that angle is our opposite side. Across from the 90 is the hypotenuse, and then the leftover must be adjacent. This time we know the adjacent. We are trying to find the hypotenuse. So again, we reference this abbreviated shortcut acronym to let us try and help us figure out which trig function to use. I know the adjacent, I need to find hypotenuse. That's AH. Looking at AH, I know it's got to be cosine. So the cosine of my angle, which is 43 degrees, is going to equal to adjacent over hypotenuse. Now, one common mistake is that people always tend to try to put the variable on top. It really doesn't matter. The only thing that stays the same, the only thing that stays consistent is that it's going to be, cosine is going to be adjacent over hypotenuse. And so this time we do have a variable in the denominator, which will just require one extra step. E times the cosine of 42 is equal to, the other direction is just 12 times 1, so we can write that as 12. Now I need to get E by itself, so I'm going to divide by the cosine of 42, both sides. And so E is equal to 12 divided by the cosine of 42 is 16.147. We'll round that to 16.1. So that 4 tells us to just leave that 0.1 as is. All right, one last example down below. We've used sine, we've used cosine. Let's see what we've got here for number 3. So I'm going to circle number 34, or angle here is 34. Across is always the opposite. Across from the 90. We never use the 90 in the right triangle trig. We just need there to be a 90. Across from that 90 is the hypotenuse, leaving us with adjacent here. We are looking for the adjacent side. We know the opposite side. Reference back to SOHCAHTOA, we need OA. Which trig function uses OA? And that is tangent. So we're going to use the tangent of 34 degrees is equal to, opposite is 15, adjacent is K. And again, we follow, just as SOHCAHTOA says, TOA, tangent, opposite, adjacent. Cross multiply x time, or K times the tangent of 34 is equal to this direction. 15 times 1 is 15. Now we're going to have to get K by itself, so I will have to divide by the tangent of 34 here. and k is equal to 15 divided by the tangent of 34 is 22.2. I would practice using your calculator here. Make sure that your calculator is set to degrees, whether you're using your iPad or perhaps a scientific calculator of your own. Make sure that you are in the correct mode. All right, the next couple examples are going to be kind of real life examples, but really it's just finding right triangles and not a ton different. We may have to label a couple of sides of our own. So let's see what we've got here for number 4. If the segment BC has a length of 45, so that's this base down here, find the height of the tree. All right, so I'll call that my H is height. So now we've got a right triangle. It's a tree this time, but really nothing has changed. We're still going to start with our angle, go across to opposite. Across from the 90 is my hypotenuse, leaving us with this side as the adjacent. And we now need to determine what trig function to use. I know I've got opposite here, and this is my adjacent. I'm looking for opposite. I know adjacent, OA, tangent. The tangent of 35 degrees is equal to the opposite is h over the adjacent side is 45. Put a 1 underneath the tangent so that you can set up your proportion. Cross multiply this way. 45 times the tangent of 35 is equal to h. And now you're just multiplying 45 times the tangent of 35. And that answer is 31.5. And we don't have a unit here, but if there were, we would want to attach units to that answer. Moving on to number 5. The shadow of a flagpole extends 13 feet. The angle of elevation from the ground to the top of the flagpole is 40 degrees. So we've got a flagpole. The shadow of that flagpole goes backwards and extends 13 feet. The angle of elevation from the ground to the top of the flagpole is 40 degrees. So you've got a 40-degree angle right here. We need to find the height of the flagpole. And so we assume that a flagpole is standing at a 90-degree angle, otherwise it wouldn't be a very well-designed flagpole. And we need to figure out the height, so we've got to use a trig function. We are going to, again, circle our angle. Across is the opposite. Next to is the adjacent, and across from the 90 is the hypotenuse. And we're going to use tangent here again. This is similar to question number 4. The tangent of 40 degrees is equal to opposite is h over adjacent is 13. Cross multiply this direction. H is going to be the tangent of 40 times 13. And the height is 10.9. Finally, number 6, a balloon is tied to the ground and the string is 20 feet long. The wind is blowing the balloon, so the string has an angle of 70 degrees with the ground. So if you imagine we've got a stake in the ground and the balloon is tied to that stake. Here's the balloon. The wind is blowing the balloon at an angle. The string there's 20 feet of string. 20 feet of string here. And we need to try to figure out how high the balloon is in the air. So we're trying to figure out the h over here. We do know that this angle of elevation here from the ground to the string is 70 degrees. So just like every problem before, we always want to start by circling our angle, going across to the opposite side, and calling that our opposite. Find the 90 across from that is our hypotenuse, and then this resulting side down here must be our adjacent. Now, we're not going to use the adjacent, but it is helpful to always just label it, make sure you have it there. We need to use a trig function that uses opposite and then hypotenuse. Opposite, hypotenuse, OH. Looking back to your SOHCAHTOA, the trig function that uses OH is the S, and that is sine. So you use the sine of 70 degrees is equal to opposite is h, hypotenuse is 20 feet. Put a 1 underneath it, cross multiply. You've got h times 1 is h, and the other direction you've got the sine of 70 times 20. When you multiply those two things together, h is 18.7938. We need to look at this 9. It tells us to round the 7 up, so our height is 18.9 feet.